Okay, time for our last talk this morning before we have our lunch break. So, James and Wade, I'm going to introduce you. Wade Lewis is an immersive technology application engineer at APL. He's passionate in covering ways to leverage immersive and emerging technologies to bring human-centered solutions to life with current and future warfighters. He's a member of the XRCC team and also of our Tactical Advancements for the Next Generation program's holodeck team. His experience in the creation of interactive and immersive real-time 3D experiences, hands-on software development with a broad variety of AR and VR devices, user experience design, and rapid prototyping. His project work of visualization and simulation ranges from medical triage in the battlefield and high-risk scenarios to future concepts undersea, at sea, and in cislunar space. James Dean is an immersive technology applications engineer at APL as well in the XRCC team. He has experience developing immersive tech for several fields, including computational fluid dynamics, research, site feasibility and analysis, unmanned underwater operations, and emergency care training and operation. He has extensive expertise with the Unity and Unreal Engine, including GPU and graphic rendering programming, as well as expertise with the utilization of XR hardware. Please welcome Wade and James.
All right. Thank you all for joining us. And Brandon, that was a great presentation, by the way, super energetic. So this presentation is going to highlight a lot of evolutionary milestones that the XR technology has reached throughout the last, 5 to 7 years or so. But while we talk about these slides and showcase some of the highlights or the evolutionary milestones, I really want to impress upon everybody here that at this point in time, the technology, the immersive technology, has reached a point that is no longer a gimmick. It is now useful for virtually every industry that people here are involved in, especially here at APL. The technology, the barriers of entry to the technology, to using the technology, to developing with the technology, have reached a point where, effectively, if you are not seriously considering incorporating XR technology in the work that you do at this point in time, you are in very danger of falling behind in terms of improving your bottom line. And so, just to give you kind of an example of some of the work that we've done here at APL, this is just a small set, but we've tested a lot of XR hardware. We have developed a lot of apps. Some of these I'll explain in a later slide here in this presentation. But really, the ultimate thesis of this presentation is that at this point in time, XR is now useful across numerous industries. And I would argue virtually every industry at this point in time, not just in entertainment. Again, headsets are relatively cheaper and easier to get into. The applications for developing are coming out with new features, new capabilities, new tool sets for you to utilize. And the software that exists to help developers work is improving to improve their turnaround time. And so while there isn't going to be an application that fits all of your team's needs at this point in time, developing an application that does fit all your needs is now becoming much, much easier than it was, say, 5 years ago. So again, seriously think about how or if and should you incorporate XR technology into your workflow, because it's here, it's ready, and it's mature. So with that getting started, let me talk about a little bit on the milestones of XR hardware. To start with, hand and body tracking technology. Initially, it didn't really exist in a classical form. Back when, let's say, 2016, 2017, when the HTC Vive came out, I'm going to kind of get some of these names a bit wrong because memory's long term. When you got these headsets, they came with lighthouses that you had to set up around the room in strategic locations. And those lighthouses were the devices that actually tracked the orientation and position of the controllers and the headset, right? So at this point in time, the only relative hand tracking you had for this hardware was with your controllers and your headset. And some software, some applications during this time that tried to do body tracking did heavy guesstimations based on the orientation of your head and your controllers. Now, when Ultra Leap Motion Camera came out in 2013, as well as the HoloLens 1 and the Quest 1 headset, that was the first time that actual direct tracking of your hands came out. And besides the Leap Motion Camera, which is actually a very fantastic device for a first run, the HoloLens and the Quest 1 headset really only tracked your index finger and your thumb and really only understood this shape of your hand. If you did anything more complex, like hand gestures like this, or hand over hand in particular, it would lose tracking immediately and it would fail. And then when the HoloLens 2 came out, as well as the Quest 2, and now also like the later versions of the Meta Quest Pro headsets and everything, they incorporated machine learning and AI algorithms and training algorithms such that now you can track very complex hand gestures, very complex hand movements. You can do, as Blake had shown earlier, putting fingers like this. This is now trackable. And hand over hands and everything too. So at this point in time, and this is, I don't know, 2019, 2020, maybe even 2021 at this point in time, this is now becoming a mature enough feature that is effectively standard across many enterprise level or many consumer focused headsets. And it also is becoming an enabling technology because now you can really really understand the intention of the user based on the gestures of their hands. In terms of body tracking, however, again, back then, there really wasn't any. It was just kind of guesstimations based on the controller orientations ahead. But the HTC Vive first came out with their Vive tracker, which is kind of a weird-shaped puck. And you would have to attach them to either the physical component or to your body to track various parts of your body and use some rudimentary form of body solvers to kind of get a better idea of what your body's doing. Once that came out, it evolved very rapidly to a point where now you can have multiple trackers on your person, and you can use machine learning algorithms or what's called inverse kinematics, which is actually an inverse solver to enable or to ensure that your virtual body is not doing anything too extreme. But this is evolving faster and faster to a point where now, as Blake mentioned in his earlier presentation, they're using cameras that are externally facing on both the headsets and the controllers, as well as additional sensors, and just trying to get an identification of the physical space surrounding it, using machine learning, using AI, using all these tool sets. So now it's becoming much easier for all of us to do fairly basic level body and hand tracking at a point where it's good enough. Maybe not quite motion caption level quality, but it's racing fast towards that. Other new milestones. Eye tracking takes its own slide here because the Vive Pro Eye was the first commercially successful headset to come out for consumers that had eye tracking at all. And not only this device was able to track where you were looking, but it was also able to track the dilation of your pupils. So it could track if you had light sources, your pupils would like what the inverse of dilation is. This unlocked a new evolutionary path for XR as well as the industries of which XR is touching. I say that because Dr. Blankhorn mentioned foveated rendering. This is what enables dynamic foveated rendering. Eye tracking is absolutely essential for that to work. Additionally, now with eye tracking and particularly pupil dilation, you now have an avenue of human performance assessment and human performance training. Now you can look at how is the performer operating under duress or under a stressful environment. You can say, you can now get discrete data sets that identify if the user is distracted or not. Maybe you can assess how much attention they're paying towards the task they're doing. And so now you start getting into the realm of human performance. And this was unlocked with eye tracking technology. So, of course, back then it was kind of rudimentary. The frame rate or the capture rate for eye tracking was relatively slow. I think it was like 30 hertz for the HoloLens 2, even for the Vive Pro Eye. But with each subsequent headset, it's becoming faster frame rate to capture. And this feature has become so important in the XR industry and for the the industries of which it touches, that newer headsets that have been coming out in the last year, year and a half or so, have this feature as a standard. And so, again, this is one of those technologies that really created a new evolutionary path and just opened up a whole lot of possibilities for the industries, the XR industry as well as the industries that that touches upon. So with that, I'm going to give it up to Wade here to talk about the software.
Yeah, so we talked about the hardware, but a big question is how does that hardware talk to our applications? And so earlier, Blake mentioned OpenXR. This is a standard that we've been paying a lot of attention to because it has made our lives so much easier. So what is OpenXR? Well, it's been under development by the Kronos Group. It started in 2017. It was gaining popularity in 2019. But we've actually seen, I would say roughly summer or fall of 2021 is when many of the larger companies actually bought into this and started saying that it's not just the preferred option, but it's something that they really are saying, like, you should be using OpenXR in all of your applications. So again, like, why do we really care? Well, the idea is that it's necessary to use this to reduce platform fragmentation. And also just to hit on some other things here, we've seen a lot of support for Unreal Engine. We've seen it in Unity. We've seen this in SteamVR, and we've actually seen it in all of the underlying software in various headsets, such as the MetaQuest platforms. So a little bit of a busy slide here, but we're going to go on a journey, I promise. So the left side is what it used to be like developing an XR application. On the right side, it's what it's like today. And so just to walk you through this, starting on the left side at the very top, let's say we want to develop a VR app. We need to pick our game engine of choice. Just for simplicity's sake, we're going to go down that left side and say Unity. But now we want to support a headset. Let's say, since this was probably 2017, 2018 when this image was made, let's say we're picking like the HTC Vive. Well, what platform do we want to develop this for? When we tell the controller that we want to pull the trigger, how do we write that code into our Unity application? So we're going to leverage something like SteamVR. But now it's 2018, 2019, and the Windows Mixed Reality VR headsets have been, picking up some popularity, and so let's support those. Well, we could use SteamVR, but what if we want to take advantage of some of the, let's say, very specific things that the manufacturers have been developing, such as the Oculus integration released hand tracking in late 2019, I believe it was December, right before Christmas of 2019. I was like, the day it came out, I was like, I gotta try this. But the problem was, it didn't work with SteamVR. The only way to use the hand tracking was to use the Oculus-specific code. So now any applications that we've developed that use SteamVR just simply did not work. They didn't take advantage of those features. And so how do you do this? You have to, what we ended up having to do was every single time that we wanted to develop something that is as simple as pulling a trigger on a controller, we had to develop it for the platform. And for, in cases like AR/CPR, where the headset is a question, right, because it's more about the user than less about, what platform we're targeting, it's very hard to transition if you don't have some kind of standard or way to do this. And so where we are today with OpenXR and why this has been so amazing is because, again, let's take that leftmost side and say, okay, we're at VR app number 1, we're picking Unity, and now we tell OpenXR, hey, we just want to pull a trigger. I don't care whether, what platform that's on, what it's supposed to do, just tell me when that trigger action happens, and then I'm going to have my Unity app do some kind of code. And so now we've sort of uncoupled the actual hardware side from what the game logic or Unity's or Unreal or WebXR logic needs to do, which is super, super important because we can focus more on how do we write the code and solve our problems and less so about let's deal with all of this other stuff that has to be done just to make the XR, VR, AR device work. And so the other piece that I have on here is there's this little section called Development Tools with 2 arrows going to each of these spots. And another big piece when we talk about software is how do we actually make these things? Because of course, so we went from the hardware and how does that enable us to build certain experiences to how does the hardware talk to the software, and then we get to software development kits and the development tools that we have. Now, an SDK is a collection of development tools, assets, libraries that allow developers to create some really awesome things and can accelerate cross-platform XR development and support lots of different features. And so I listed a bunch on this slide, such as MRTK, there's the Oculus integration package. They still haven't changed the name. That's like the only, other than the Oculus PC app, that's like the only thing that still has the Oculus name on it. But they have a interaction SDK, a locomotion SDK. Actually, just yesterday I was reading about there's an audio SDK that can have spatial audio that's improved more so than what the standard like Unity or Unreal spatial audio can do. And you know, there's a bunch of different ones out there. Leap Motion provides one that works with their hand tracking. And actually, MRTK, Oculus, and Ultraleap also all support both hand tracking and controllers, which is super cool. And then there are a ton of ones that have been made by other companies that, and so for example, ones on the Unity Asset Store, one of the most popular ones is the VR Interaction Framework. So I've listed all these out, but why do we care, right? What do they do? Well, the idea here is it provides a bunch of different either assets or, like, for example, that Ultraleap one there is providing a whole UI panel with different buttons, toggles, sliders, items, whatever you might need. And so, you know, we can say, well, a UI is a UI. Why do we really care? The problem is, when you are doing something on, you know, say a smaller budget, you have in terms of weeks or months to produce something. I'm not, you know, sitting here. We don't have 5 developers who have 4 years to make some kind of game. We're saying, hey, I have this really cool idea, but the sponsor wants it in 3 days. How do I make this happen? Well, we go here and we say, I can get some buttons that are already pre-made. People have spent all of this time perfecting it, that the button actually depresses in. We get audio. Maybe there's some kind of hover when your finger hovers over it. You get audio when it hits the button, and then when the button's fully closed, and when the button comes up. And so there's all these little things that can go into this that simply, you know, your average developer does not have time to work on. And so that's really the power of these software development kits. We can say, how can we accelerate our development by using these and really push this forward? Now I'm going to turn it back over to James, because we've talked about how we develop these and a lot of the interfaces around them, but then there's also all these other amazing pieces of software that we can leverage in our applications.
Yep. So to give kind of an idea of just how powerful some of these assets and features are, there's a talk that Annie and Blake are going to give later on today, I think in the extra room, to talk about GIS, or Geographic Information Systems, and how important they are to a lot of the work that APL does. And I bring this up because the 2 major players for game development in using GIS is Cesium and ArcGIS. They're basically direct competitors to each other. They are providing a very robust series of packages and assets that allow you to do a lot of GIS-centric data analysis and data visualizations. And it's almost virtually out of the box. So depending on which game engine you try to utilize, you can quite literally grab it for free, bring it into your project, and it's ready to go at a very basic standpoint. They even provide a lot of documentation tutorials. They have sample projects, depending on which game engine you use. It's very simple to get into. It's very simple to utilize right off the bat. And I do want to mention, so this is an example of me actually using the Cesium plugin in Unreal Engine, I think 5.2, or no, I'm sorry, 5.0. And the reason I bring this up is because Unreal Engine 5.1 made this official using large world coordinate systems. Underneath the hood, what they've done, well, a little bit of background here. In order to make game engines as performant as possible, when you're doing location-based computations, you really don't want to have a large memory footprint per each computation, because you're going to be pouring hundreds of thousands of computations per frame. And so that boils down to performance and optimization. And so typically what would be done is you use single point or single precision floating point values to get those transform computations. What Epic has done with their Unreal Engine 5.1 says, we're going to switch that to double precision floating point values. And we can do that because the hardware quality, compute quality, GPU quality is enough that we can get away with it without worrying too much about performance. So they pretty much flipped the switch on that. Now all of a sudden, we can get massive worlds rendered in this engine. I think, so there's a bit of a typo here. I say that there's a distance of 88 million kilometers. It's an area of 88 million kilometers squared, which is still longer than the circumference of the Earth if you go in one direct line. So we can do accurate computations of positions in real-world coordinates in very, very, very large spaces without having to do any sort of numerical manipulations or numerical wizardry to kind of compensate for the lack of distance measurements or distance computations. And this is a unique feature to 5.1. It's also in 5.2. It's kind of a standard feature now for Unreal Engine. No other game engine has this capability as of this point in time, but it's going to be coming down soon. So with that, I mentioned I wanted to highlight a couple of projects that APL has done thanks to the maturity levels of the capabilities and technology of XR. So let me kind of quickly go through some of them. The first two are Mammal and Rovar, which are two AR projects that I've developed. Effectively, if you are an underwater ROV operator and you have no idea what terrain or landscape you're operating within, Rovar is used to generate or to use the sensor systems, the LiDAR systems of the ROV itself to generate a three-dimensional point cloud representation of the terrain in real time as you are operating in it. So this helps you navigate the space you are in when things like the sonar camera is very confusing or things when the water itself is so cloudy that you can't actually see out the cameras. On the other side of this, for Mammal, this is more of a UUV swarming operation standpoint. You have multiple UUVs patrolling a certain area. You as the coordinator need to have an understanding, an immediate understanding of what the situation is across the area of interest at any point in time, so that when an alert happens or when some incident happens that you need to be aware of and make rapid decisions, you have the full understanding of the context of the system and its operational environment. I can't speak too much in DARPA L2M because I was not a part of that project. I believe you want to speak to Blake Shores for details on that. But for Glass World, this was an earlier proof of concept application where you would have a robot or a platform or something that is sending out LiDAR signals across a space, and it's sending in the telemetry data or the LiDAR data sets to an AR headset somewhere else to allow the operators to see what is actually behind these physical walls that it can't safely walk past or walk through or walk around to see. Of course, we mentioned AR-CPR in the previous presentation. Another one for training and performance was a proof of concept called Glovebox. Effectively, if you do not have a facility, well, the story behind this is that we wanted to help the individuals who would be handling extremely dangerous biohazardous materials inside of a lab facility and train them on getting used to operating within this lab facility before the lab facility was actually built. And so we had the models of the facility, we had the models of the components and the tool sets that people are going to be using inside of this facility, but it didn't exist yet. So we wanted to see how feasible it was to create this environment, to have the users train inside of this environment and get them ready for the environment for real time when it's actually time to handle extremely dangerous biohazardous materials. In kind of in the same vein of explorations and getting accustomed to the buildings, we had building exploration features where we developed a Gibson Library XR Tour, which is a WebGL application. When our Central Spark facility was currently under construction, again, we had the CAD models of the building, the facilities, and we were able to bring in the furniture, the tools, the hardware, the capabilities into the space to allow users to be like, hey, go ahead and play around in this virtual space so that you know or get yourself oriented in the space so that when it's actually physically there and you can go into it, you know where you are and you won't get lost. Same thing for the Building 201 virtual tour. We had, again, CAD models, put that into a VR environment. This was showcased and demonstrated while this building you're in now was currently under construction. And it actually opened up further avenues of saying, well, during the construction process, if there are any errors or any adjustments, we can go back to the VR space to see, oh yeah, this air duct was actually supposed to be turning that way but now it's turning this way, and it's going to collide with all of these other systems now. So it's solving problems before they become serious problems. And these are the kind of capabilities that XR technology at this point in time will help you out with now. So with that, I think I'm going to hand it over to you.
Yeah, and so, did I lose my mic or my back? All right, you're back. So wrapping this all up, because I know we're all probably hungry and about to go to lunch, but bringing this back all the way to Nick's presentation that kicked us off this morning, talking about XR as a service. We've had all of these tools that we've talked about both on the hardware side, the software side, but ultimately what this comes down to is how are we enabling developers to go and do all of these awesome things. We talked about ARCPR and many of the other projects that we're doing at APL that are right now, this was mostly all worked on or in part worked on by our XRCC team, but we're not the only ones doing XR work at APL. And so what's really awesome is we're trying to say, how can we enable everyone else at the entire lab to do this? But we don't want to have everybody, every single team needs to say, well, what headset do I want to do? They have to buy all the headsets. They have to try it out. They have to weigh the different alternatives, understand the difference between Fresnel lenses and pancake lenses. What we want to do, really, is be able to say, hey, what we recommend is you should have this type of headset because we've demoed it before, we've done these things with it, we've already solved the security issues, we know where the pitfalls are. So how do we enable people by training them, whether that's teaching various courses, we have internal APL courses that will teach, producing documentation about, hey, this is how you get it to work on APL's internal network. We have innovation spaces where we enable people to go play around with it, have fun with the devices, and figure out what the hand tracking works. The only way you're going to know if you can really cross your fingers or if that doesn't work is by doing it. And so let's try that out and play with it. How do we work with different pieces externally, collaborate with other communities, and how do we get the software in that we need working at APL? And so ultimately, this is where we end up, and one of our big goals of the XRCC, or the XR Collaboration Center, to push this technology forward and really make it so that we're not just trying to say, let's do XR for cool XR things, but we're saying, let's use this technology to actually solve problems. And I myself had a moment this past spring where I was working on an application, and I realized that as we got through this development process, we weren't just building an experience just to say, like, hey, let's put people in VR, it's fun. What we realized was we were actually solving a problem for the warfighters. And even the sponsors were like, well, this is great that you're doing rapid prototyping in VR, but what we really care about are those underlying needs of the warfighter, and how does that impact their day-to-day lives? And so that's ultimately where we're trying to go, is using this as a tool to solve real-world problems.
So we're a little bit over time, but we're happy to take on any questions. Also, we'll be sticking around the area if you want to come talk to us directly about the presentation as well. But in the meantime, thank you all for sticking around, and go get some lunch.